electric current through a conductor is equal to charge per unit time. Apart from that, you need to identify another term, the quantization of charge. So you need to understand that electrical charge is quantized. That is, it comes in discrete amounts. So, which is because the smallest possible charge value is the charge on electron, which is also called elementary charge value, 1.6 times 10 to the power minus 19. So every charge value should be an integer multiple of this, because the charge on the smallest charge particle, which could be either electron, is negative 1.6 times 10 to the power minus 19, or on proton, it's going to be positive 1.6 times 10 to the power minus 19 coulombs. So if there are 2 electrons involved, it will be multiplied by 2. If there are 3 such particles involved, it will be multiplied by 3. So it can't be anything in between 1.6 negative 19, or 2 times 1.6 negative 19, or 3 times 1.6 negative 19, and so on and so forth. So it has to be an integer multiple of the elementary charge value, which is why he said that the amount of electrical charge is quantized, and it's an integer multiple of this value. And then, guys, we have this, again, the formula, which is electric current is charge upon time. So we will rewrite this formula into more possible ways. And one is that we'd say that if Q is the electrical charge, then it must be equal to N times E. N is the number of charged particles, which in most of our cases would be the number of electrons. And E is the elementary charge value, that is the charge on electron. So total charge must be number of charged particles multiplied by charge on each charged particle. All right, great. So guys, I've just done a bit of a rearrangement. I've put the elementary charge on the other side, and I have written out N upon T equals I upon A. So this N upon T is the rate of flow of electrons, and that's equal to I over elementary charge value. So be prepared for it. Sometimes examiner gives you the electrical current, and he would ask you to find out the rate of flow of electrons. So if you're being asked to find out the rate of flow of electrons, you divide the current by the elementary charge value. For instance, अगर आपको दिया जाता है कि electric current 10 amperes है और rate of flow of electrons क्या है, तो आप कहेंगे सर 10 को elementary charge value से divide कर दीजिए, and you will get yourself the rate of flow of electrons. Just be prepared for that, right? Ever you're being asked to find the rate of flow of electrons and you know the current value, you have to divide it by the elementary charge value. Let me try and explain you another current expression. The derivation is also very important, and the formula, this formula is going to be given to you in formula sheet. But I mean, starting off with the same concept, that electric current is the rate of flow of charges. You can also write electric current as NALQ. What is N? N is called the charge carrier density. It is a charge carrier must be probably be electrons. So how many electrons are there per unit volume? That's the charge carrier density. So if charge carrier density is number of charge carriers per unit volume, you multiply it by AL. A is area of cross section, L is the length of the conductor. So AL becomes volume. Charge carriers per unit volume multiplied by volume would be the total number of charge carriers, multiplied by the charge again would again be the total charge. And then guys, I need to make a bit of a rearrangement here as well. N is copied as it is. A is copied as it is. Q is copied as it is. And L over T, I've written down separately. L is the length of the conductor and T is the time taken. So that gives you another quantity that's called V, the drift velocity of the charge carriers, that how fast the charge carriers are traveling. So we replace L upon T by V, and we call it drift velocity, and we understand it as the speed at which the charge carrier. So how is area of cross section connected with the drift velocity? So smaller area of cross section means A and V are inversely proportional. So electrons would be traveling more fast in a smaller cross-sectional area as compared to the larger cross-sectional area. There's something that examiner most asks is something I'm telling you, that area narrows and drift velocity increases. More importantly, another one point that I would want you to understand is the charge carrier density. So when we say that copper is a better conductor of electricity as compared to other most metals, Then why is that so? Because copper has a greater charge carrier density. So if a particular conductor has a greater charge carrier density, so that means the current would be directly proportional to it. It will allow more current to pass through, and hence it will have lesser resistance.